remains constant, or we can say what? Also we can say conserved. Both are same, constant or conserved, provided no external force are acting, provided no external force acting. Are you clear? That is what. So if external force is acting, then again the conservation is not constant. So only two bodies are involving, or more than two bodies also, but the external force should not be act, then their momentum is always remains constant or conserved. That is what law of conservation of momentum will say. Is it okay, everybody? Yes. So this is what a body gains momentum, then some other body must be lost an equal amount of momentum. So that is why we can say that momentum is never created or destroyed. Is it okay, everybody? So suppose if Harish is receiving the 20 kilogram meter per second momentum, then some other person, let me take now Reddy is going to lose the how much momentum? Reddy is going to lose. Suppose Hari is gaining 20 kilogram meter per second momentum, means Reddy is going to lose how much momentum? 20 kilogram meter per second. So if anybody is gaining some amount of momentum, means definitely some other person or some other body should lose same and equal amount of momentum. Is it okay, everybody? Everyone?
Yes.
You understand? So if suppose if this person will lose 100 kilogram meter per second, then this person will never gain 50 kilogram meter per second, because whatever the momentum lost by the body, the same momentum will be gained by some other body. Is it okay, everybody? Yes, please. Mitakshri, Vartani. That is what. So that is only we used to call it as law of conservation of momentum. So we can say that momentum is never created or destroyed. Please remember, or we can say momentum is neither created nor destroyed. Your choice. Momentum is never created or destroyed. Momentum is never created or destroyed. Is it okay, everybody? Yes, please respond. So this is only we used to call it as what? Law of conservation of momentum, or we can say, remember, principle of conservation of momentum. What we can say? Principle of conservation of momentum. Anything you can say. Okay. Now, if you'll observe very carefully, principle of conservation of momentum, understanding, is in accord with the Newton's third law of motion, which says that if every action there is a reaction, and both are in what? Equal and opposite. Understand? That is what you have to remember. Like same way, when two bodies are colliding each other, when the two bodies will collide each other, so we can consider that momentum is exchanged. Is it yes or no? Yes, please respond. So when the two bodies are collision, we are saying that momentum is exchanged between the bodies. But suppose this is the big car, okay, and this is the small car. Now, when they will hit each other, when they will collide each other, momentum is exchanging. Understanding? But the total momentum remains what? Total momentum remains constant, or we can say conserved. So means in the sense of, if you will notice it, for example, big car is exerting 10 Newton force, then small car also will exert how much force? Maybe its mass is small, but the force exerted by it is what? Always equal. That is what, there is every action, there is an equal and opposite reaction. Are you understanding? So the size of the body is not a matter. How small or how big is not a matter. If I'm exerting 100 newtons on force, then that another body is also exert how much amount of force on me? Same 100 newtons of force only it will exert. That is what we can say. The Newton's third law of motion, which always will says that action and reaction are equal and opposite. Action and reaction are equal and opposite. That is what Newton's like conservation of momentum also it says that the momentum lost by one body which is equals to the same and equal momentum gained by the another body. Is it yes or no? Yes?
Yes, sir.
That is what
Yes, sir.
everybody should remember. Now, we are going to prove that mathematically. That is what to prove the law of conservation of momentum. Shall we prove law of conservation of momentum? Everybody?
Yes, sir.
Yes. So to prove the law of conservation of momentum, we need two bodies. One body is a truck and another body is a car. One body is what, guys? Everyone? One body is truck, another body is car. So we can keep adding to prove law of conservation of momentum. Law of conservation of what, Hari? Momentum.
Momentum.
Okay. So now listen very carefully. So we need for that how many bodies? Let's consider two bodies. Two bodies. What is the two bodies, Hari? One is truck, another one is car. One is truck and another one is car. Suppose. So right, remember, let's consider two bodies. Consider two bodies. That is what truck and another one is what, guys? Car are moving in the same direction. Moving in the what? Moving in the what? Everyone?
Same direction.
Same direction. That is what you have to remember. Now, let's consider one truck, everybody. So now, truck before collision, what is the velocity? Anybody can tell? Truck is having some mass. Yes or no? Yes, please respond.
Yes,
Yeah, it is different speeds and velocities. You can remember. So these both are moving with what? Moving the same direction, but with different velocities. Different velocities, or we can say speed. Now, you tell me, let's consider this is what the truck. Everybody. So see the truck, how to draw very easily. So we can make one square box first. Later we can take the bend and we can draw it. That's all. So that simply we can draw the truck like this. This is what, Hari? Kaushik, have you understand, Kaushik? This is what the truck we can say. Now let me consider what is the mass of the truck. Mass of the truck is what? Mass of the truck is, what is that? Anybody? M1. What I will consider? Mass of the truck is M1. Understanding? Now, same way I will consider a car. Now you can notice it car. So this is what my car. So this car mass, what I can consider car mass? Mass of the car. Mass of the car. Please tell me. Mass of the car is equals to M2. Is it okay, everybody? Yes, please respond.
Yes.
It is having M1 mass and it is having what? M2 mass. Are you understanding? Now, initial velocity of the truck is what I can consider. You have to tell me. What is the initial velocity of the truck? Initial velocity, please let me consider of the truck is U1. What is that? U1. And initial velocity of the truck is, car is, what I can consider? You can tell. U2. What I can consider, guys? What I can consider? Let only I'm saying. Now, this is what before collision or after collision? Before collision. What is that? Before collision. Everyone, please respond. Before collision. That is what? Now, after collision, what is the velocity? Tell me. After collision, it will get the final velocity. So, after collision, final velocity is equals to what I can consider. By this time, you must get V1. Okay, after collision, final velocity is equals to final velocity of a car, which is equals to what I can consider?
V2.
V2. This is what? Any doubt? Till here, ask me. Mitakshri, have you understand this one? I consider that one is truck and another one is car. Both are moving in the same direction. Let you want to keep even towards the east direction. Towards the which direction? East direction with the different velocities. Is it okay, everybody? Yes, please respond, all of you. Now, let me consider, now both the bodies are moving in the same direction or opposite direction? Same direction. Okay. Now that is what momentum before collision. So I'm going to draw that. Observe very carefully. This is what the truck. See here, everyone. So you can understand very easily. So this is what is this called as, guys? Truck. Truck, what is the mass? Mass is m1 and it is moving like this direction. What is the velocity? Velocity is what? u1. Okay. Now this is the car. This is the car. What is the velocity of the car? Mass is m2. And what is the velocity, guys?
U2.
u2. Okay. Now this is what, let me consider momentum before collision. Momentum before collision. Tell me what is the momentum before collision, everybody? Momentum before collision, everyone. What is that? Momentum before collision. Momentum of the car. That is a momentum of the truck plus momentum of the car. So momentum before collision is equals to momentum of the truck plus momentum of the car. So what is the momentum of the truck? You should tell me. You all people knows. So total momentum before collision is equals to, please remember, this is truck here. So total momentum before collision is equals to momentum of the truck. Momentum of the truck means what? Multiply and tell me. Mass of the truck to velocity of the truck plus momentum of the car. Everybody.
Into U2.
Mass of the car into velocity of the car. Is it yes or no? Everyone? Will you accept
Yes,
it?
sir.
We have to prove that. We are making it. We have to prove that. Next. During collision, they will collide each other. Collide means what? Truck, they are moving with a different velocities. So this is what the A before collision. Now B, they will collide each other. Understand what will happen? Collision will take place. Collision means what? Accident. So truck will come and will hit the car because a car may be moving fast, slower, or truck may moving faster. So car will come and collision. Both will collide each other. Is it okay, everybody? Yes or no?
Yes, sir.
So some sparks
Yes,
will
sir.
come, some damage will be there. So collision will take place. Now, collision after, again they will travel in the same direction or different direction because both are moving in the same direction. So suppose Reddy is driving a car, Hari will come and will hit with his lorry. So that still both will move in the same direction or opposite direction. Same direction.
Same direction, sir.
Same direction only. That is what. So after collision, some damage will happen or not for your car and a truck also. So that is what damage we can show. So this is what the damage. So after collision also, mass of the car is, mass of the truck is same, but velocity is what? Velocity become V1. Understand it? Now, truck also some damage in the backside. Yes or no? Vardhini, Mitakshri, truck is some damage in the backside. So that is what its mass is remains constant. But after collision, what is the velocity? After
V2.
collision. After collision. So that what is our velocity, guys? V2. Is it okay, everyone?
Yes,
Please
sir.
respond. Now, what is the total momentum after collision? Tell me. Total momentum after collision. You have to tell. Total momentum after collision. Everyone. After collision, what? Total momentum after collision equals to momentum of truck plus momentum of car. So now, momentum of the truck after collision, what is that? Everyone,
M1 V1,
you
sir.
have to speak M1 V1 plus momentum of the car.
M2 V2.
V2. So this is only. So according to the Newton's, law of conservation of momentum. What is law of conservation of momentum? Momentum before collision is equals to momentum after collision. That is what that. Is it yes or no? Momentum, conservation of momentum. Yes or no, guys? Please respond. So we can say conservation of momentum is equals to, what do you mean by conservation? Conservation of momentum, which is equals to momentum before collision, which is equals to momentum after collision. Yes or no? Yes, please.
Yes, sir.
That is what. So this is what actually we have to prove. So we'll prove it in the next class. Let it be. It's now already time out. So now we'll stop it here and we'll prove. So what is the momentum before collision formula? M1 U1 plus M2 U2, which is equals to momentum after collision. Tell me. M1 V1 plus M2 V2. So this is what conservation of momentum formula. So this formula we have to prove. How to prove? So this formula will prove it in the tomorrow's class. Okay, guys. So till here, any doubt, anybody ask me? So I understand momentum before collision, momentum after collision. Change in velocity will take place, but mass is remains constant. Who will change, Akilan? Only momentum, velocity will change. Okay, but momentum before collision is always equals to momentum after collision. So that derivation, everything will prove in the tomorrow's class. Is it okay, everybody? Yes, please.
Yes, sir.
That is all. Okay. Thank you. Thank you, everybody. So with this,
Okay, sir.
we'll meet in the tomorrow.
Thank you,